Thank you for the introduction. Hello, everyone, and thank you for taking the time to attend our seminar about thermo-latent curing agents for low temperature 1K epoxy adhesive applications. It's a pleasure to have you here today in this virtual innovation day, and many thanks to SpecialChem at this point for organizing this. Before we start, I would like to make a few points that are important for today's presentation and that may be worth keeping in mind for later. When it comes to designing a new 1K epoxy structural adhesive these days, especially on that which needs to cure at lowest possible temperatures, there are a few points that can be crucial in choosing the right hardener. These are in particular a long latency or shelf life of the final formulation, ideally combined with an activation temperature that is as low as possible, and also important, high reactivity above activation temperature and the capability for green strength development, as well as excellent properties of the cured adhesive such as high temperature stability and high adhesive strength. Before we proceed, these are the 5 points to take away from this presentation, basically. To introduce you to the topic we are focusing on today, we will talk basically about 1K high-strength structural epoxy adhesives, which are on the far left side in terms of a range of rather rigid to rather flexible adhesive systems. These systems are usually designed to meet highest requirements for bonding strength and toughness, as well as high chemical and thermal resistance, and thus present formulators today with a special challenge. The application areas in which these adhesive systems can be typically found are in particular automotive and aerospace, electrical and electronics, as well as industrial manufacturing. Basically, this is the main topic for today, and I'm now looking forward to guiding you through this in the coming couple of minutes. But first of all, before we dive into the topic, who are we? Since I haven't introduced myself yet, maybe now it's the right time to do this. My name is Sebastian Clermont, and I'm working for the company Evonik in the function of a technical application manager, and this at the business line Crosslinkers with technical focus on adhesive-related epoxy curing agents. To show you where we fit into the Evonik cosmos and where you can find us, we will start with a brief overview. Evonik itself is subdivided into 4 divisions, each dealing with different kinds of chemistries and different kinds of application fields. Within the spectrum, we, the product line epoxy curing agents, is localized in the business line Crosslinkers, highlighted here as a part of the specialty additives division. This is basically where you will find us in the Evonik cosmos to get a brief overview of this. We as a product line epoxy curing agents, we have the ambition to be the #1 supplier for epoxy curing agents in the world. We have a global revenue of roughly €500 million, and we are serving multiple industries active in a broad spectrum of application fields. Besides the field of adhesives, which is in focus for today, we also serve the fields of composites as well as important fields of like civil engineering with prominent applications such as industrial flooring, for example, and also the field of coatings with anti-corrosive coatings for bridges and ships, for instance. We have a global footprint with production sites as well as sales and development facilities across the world. So whenever you approach us, we operate as a global team and can therefore draw on worldwide resources. Myself, I'm localized in Europe in our production site in Marl, Germany, while my fellow colleagues responsible for the North American area can be found in Allentown, Pennsylvania. And further colleagues responsible for the Asian market are localized in Shanghai and China, just to name a few here. What is also important to state at this point, we don't formulate or produce adhesives on our own. we do need amines as well as curing agents or building blocks for epoxy curing. We as Evonik epoxy curing agents, we really support you as the adhesive manufacturer and developer. We are the decisive partner for driving material innovation, set and/or change industry standards. Overall, we offer a large and versatile toolbox of epoxy curing agents, which is combined with our strong support for an active and fast product development. Here's just a brief impression on the applications in which our products are currently used in. As already mentioned in the very beginning of this presentation, it's mainly automotive, product assembly, electrical and electronics, as well as aerospace. It mainly comprises products for 2K adhesives, but also for 1K adhesives, plus some products for sealants, in this case, adhesion promoters for PVC plastizoles. The bandwidth of products we are offering reaches basically from simple products such as Dicyandiamide and respective accelerators, such as modified amines or imidazoles for 1K applications, up to aliphatic and cycloaliphatic amines, as well as polyamides and some specialties like phenolic tertiary amines for 2K applications. And not to forget also some reactive diluents. Here I just highlighted the brand names which are of relevance for the adhesives and sealants market within our product portfolio. Some of these may already be familiar to you, others may come across in the course of this presentation. The focus for today's presentation will be in the top left area, so we are basically going to talk about Ancamine products portfolio. Basically, this is a toolbox comprising a variety of aliphatic and cycloaliphatic amine curing agents that can be used in a broad range of epoxy curing applications. So before going into more detail or coming to our products, what was our motivation to include the products to our product portfolio that I'm going to introduce you in a minute? And how can these products help you to improve the sustainability of your adhesive products? We have been reviewing the market and talking to our customers as well as to our cooperation partners. And throughout the past years, three major trends become more and more obvious to us. On the one hand, we have a high material performance comprising a superior bonding performance, ideally combined with improved performance in regard to impact, thermal and chemical resistance, as well as improved usability, which usually relates to, for example, bonding of dissimilar materials. Second major trend is sustainability, green and safe material solutions, among which reduced process energy consumption is one of the points we want to highlight here. And the third trend, cost effectiveness, which is basically about driving costs down by, for example, increasing productivity, shortened cycle times, and probably also lower curing temperatures, for instance. But also the combination of several functions in one product to become more effective plays an important role here. In the following, we want to focus on the points reduced process energy consumption, increased productivity, and faster cycle times, and also lowering curing temperatures in particular. When talking about low temperature curing 1K epoxy adhesives, which in principle means a curing temperature of 140 centigrade and even lower, there are basically three core technologies that enable the implementation of such systems. On the one hand, we have well-established systems such as Dicyandiamide, in combination with accelerators, which are capable to reduce the usually high activation temperatures of Dicyandiamide decisively. And these systems stand out due to their comparatively low price, well-balanced material properties, and usually they have a non-critical labeling. The onset temperatures, which can be achieved here, are around 120 centigrade and sometimes also lower. but with the drawback of usually significantly reduced shelf life capabilities. The second technology involves imidazoles, which enable very low onset temperatures combined with excellent material properties, but also with the trade-off of reactivity and shelf life. Here, the higher price level and labeling issues in some cases are decisive drawbacks of this technology. The last technology, or one technology, which combines low onset temperatures and high shelf life, as well as good material properties and also non-critical labeling, are the so-called solid adducts. Possible contradictions here could be the high price and in some cases the high use level of this technology. Against the background of these technologies, our ambition was to go a step further and extend the portfolio of low temperature curatives for 1K applications by products that make it possible to achieve even longer latencies, lower activation temperatures, improved reactivity and green strength capabilities in comparison to other technologies, and this ideally combined with high adhesive strength and high thermal stability. The curing agents we are going to talk about now are the so-called modified aliphatic amines. Their typical handling and cured properties are compared here to the other 1K curing agents we have in our product portfolio. And the modified aliphatic amines, they include a series of 5 products, which offer long latency combined with a bandwidth of different curing profiles and well-balanced set of properties in the cured state. Due to this, as well as a possibility to use them as sole curing agents in combination or as accelerator for dicyandiamide, we are able to offer our customers a versatile toolbox for the tailored design of low temperature curing 1K epoxy adhesives within our product portfolio. To visualize our product portfolio in a more pragmatic way, we designed the so-called tube maps, which are meant to give you a good overview of products for a certain application field and support you to find the right curing agent for your target application. The modified aliphatic amines we are talking about now can be found on the very left side of this map. Starting in this case from dicyandiamide, the next right choice for a lower activation temperature, for example, will be the Ancamine 2441. When you're looking for low activation temperatures, they can be achieved with Ancamine 2014FG and Ancamine 2337, just following the tube map to the left side. Beside these, we also offer Ancamine 2442 and Ancamine 2014 AS in case improved shelf life is required. In the following, we will now come to the products in detail and show the possibilities associated with them, and especially with regard to how they can help you to improve the sustainability of your products, in particular in terms of lower curing temperatures and improved green strength capabilities. Briefly coming back to the technologies suitable for the design of low temperature curing 1K epoxy adhesive systems, we position our modified aliphatic amines as competitive alternative to the solid adducts, but here with the potential of lower curing temperatures, as indicated here in the chart. Coming now to the modified aliphatic amines in more detail, the comparison chart shown here is meant to give you a brief overview of the properties of the products themselves and the potential when used as a sole curing agent or as accelerator for dicyandiamide. All the products are micronized powder type products, which can be easily dispersed into your epoxy adhesive formulation. A brief note at this point, the main difference between Ancamine 2014 AS and the FG grade is just the particle size, which basically leads to the differences in curing and shelf life properties shown here. As also indicated here, the potential activation temperatures, they range from around 70 centigrade for Ancamine 2337S up to 100 centigrade for the Ancamine 2441. To get a more detailed impression on the potential of the modified aliphatic amines when used as sole curing agents or as accelerator for dicyandiamide, we will now go through some experimental results on basis of simple model formulations with a special regard on reactivity, shelf life, thermal stability, and lab shear strengths. When considering the modified aliphatic amines as sole curing agents, let's start with a look on the curing onset. The thermal stability after the recommended curing schedule, in this case 30 minutes at 120 centigrade, and the shelf life in terms of viscosity increase after storage at 40 centigrade for 4 weeks. All tests are based on simple model formulations consisting of a standard epoxy resin, the respective hardener, and some thixotropic filler, as can be seen in the table on the upper left-hand side. Ancamine 2337S clearly shows the lowest onset temperature of all products shown here, with around 70 centigrade, but also the lowest thermal stability in terms of the glass transition temperature after standard curing. In case higher thermal stability is required and also onset temperatures around 100 centigrade are feasible, Ancamine 2441 is an excellent choice, whereby it also offers the best shelf life stability of all products shown here. A good compromise between these two are Ancamine 2014S and the FG grade, but the differences in shelf life must be considered, which is much lower for the FG grade due to the smaller particle size. Overall, the shelf life of all products is quite excellent, with a minimum of 4 weeks at elevated temperatures, and also expected to be even longer at room temperature, which is great performance for such products. Further, taking a look on the achieved lab shear strengths after curing at different temperatures in the range of like 80 to 120 centigrade for 30 minutes each, they clearly show that Ancamine 2337 offers the best performance with remarkable lab shear strengths, even at 80 centigrade curing, which already indicates good capabilities for fast green strength buildup. This is followed by the Ancamine 2441 and the Ancamine 2014 grades. Taking the previous results into account, Ancamine 2441, this can be seen as the best all-rounder among the modified aliphatic amines, with a good low temperature curing performance, a high thermal stability, the best one out of these products, and also excellent shelf life capabilities. For applications which require lowest possible curing temperatures, Ancamine 2337 should be the first choice, indicated by the results shown here. Let us now turn to the potential of the modified aliphatic amines when applied as an accelerator for dicyandiamide. Here it must be noted that Ancamine 2337S cannot accelerate dicyandiamide by itself, but it can further boost Ancamine 2014 or 2441 accelerated systems. This topic will be addressed in more detail when we are going to talk about fast green strength build-up later. Regarding onset temperatures and the thermal stability after the standard curing schedule, in this case, it's 30 minutes at 140 centigrade. Ancamine 2441 shows the best performance set with a remarkable shelf life at also elevated temperatures. Against this, Ancamine 2337 and the Ancamine 2014 grades are on a very similar level here, whereby it must be noted that the curing reaction of Ancamine 2337 shows a two-step mechanism. The onset temperature shown here this is the one of the second curing step detected. So in practice, it can be actually lower than shown here. Taking now a look on the achieved lab shear strengths after curing at different temperatures for 30 minutes, this time in a temperature range from 100 to 140 centigrade. Ancamine 2337S shows the best performance at curing temperatures of 100 centigrade, which again emphasizes the high potential of it for low temperature applications. Against this, the other modified aliphatic amines perform a bit better at higher curing temperatures. Overall, it can be said that all products reveal a great performance in the low temperature range, which was one of our targets. Since I have mentioned the topic of fast green strength buildup many times in the past minutes, we will now take a closer look on this. Here we performed some fast curing tests on basis of a more practicable model formulation, this time including some more fillers and tougheners. And the curing systems applied here are based on Dicyandiamide accelerated with Ancamine 2014 or Ancamine 2441, which again have been additionally boosted with Ancamine 2337S. For testing, the bond line of all lab shear samples was heated up to 190 centigrade or 205 centigrade respectively via induction and kept at the respective target temperature for 3 seconds. The lab shear strength shown here was evaluated after 10 minutes storage of the specimen at room temperature. The achieved lab shear strength values again indicate great green strength capabilities with a distinct performance advantage on side of the combination Dicyandiamide with the Ancamine 2441 and the 2337S at this point. To check the lab shear strength retention capabilities under different influences, Induction pre-cured samples as shown before, they were post-cured for additionally 30 minutes at 150 centigrade. And the lab shear strength was elevated as at room temperature for reference and compared to samples which have been aged in hot water for 7 days prior to the measurement. And in addition, unaged samples were evaluated at a test temperature of 150 centigrade with regard to the thermal stability of the bond line. And as can be seen here, the aging in hot water did not really affect the bond line performance. And even at elevated temperatures, the residual strength of both formulations is remarkably high. Again, here, the Ancamine 2441 shows some performance advantages due to its higher temperature stability, as outlined before. So before coming to the end of today's presentation, let's do a quick summary. With the modified aliphatic amines, we have a series of curing agents for low temperature 1K epoxy adhesive applications in our portfolio, which will provide you some great opportunities to improve the sustainability of your adhesive formulations in regard to higher productivity and energy efficiency. And briefly highlighting the key advantages here, our products offer a great balance of long shelf life and high reactivity at lower temperature, improved green strength capabilities, and also high adhesive strengths, as could be shown by the results we discussed previously. The applications we are targeting with these products are basically structural adhesives in the areas automotive and transportation, aerospace and defense, electronics, and also industrial manufacturing, where fast green strengths set times are favorable. And please keep our tube map in mind when looking for the right product for the application. It really can help you to find the right product. And said in other words, yeah, and comparing this to our set of targets, yeah, we deliver everything you need to improve productivity and energy efficiency of your adhesive products. If that sounds good to you and you think we can support you, yeah, do not hesitate to get in touch with us. If you want to search on your own, please take a look on our website with our product finder, which will help you to find the right products. And yeah, for more personal and specific support, please contact me for yeah, the EMEA area, or one of my fellow colleagues shown here for North America or Asia. Yeah, that's it so far. Thank you for joining and listening and spending your time. I hope that I was able to provide you a good insight into Evonik and about what we are doing. And at least I hope I was able to give you a good impression to some of our products. So we are looking forward to getting in touch with you and talk to you soon. And yeah, if you have any questions, there will be some room for it now in the coming Q&A session. Thank you very much.